Okay, so we're now going to cover the last type of proof that we're going to do, which is the angle side. So to take it back to our reference sheet to remind you what we're doing here, because this is a super big topic. So we've done side, 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 angle, side. We just did angle, side, angle, and now we're doing angle, angle, side. So take a look at what that looks like. Two angles and then the side opposite them. So now instead of that side being in between them like it was last time, we're going to basically move it over and it's going to be opposite those two angles. So side or angle, angle, side. Okay. So let's take a look at some proofs and go over some examples with angle, angle, side. All right, so here we're showing what that looks like again. We have these two angles on the side, so let's go ahead and label these like we've been doing at first. So if angle A is congruent to angle D, so that's the first angle that's congruent. If angle B, this angle is congruent to angle E, and then you have this side. So if side BC is congruent to side EF, then we can say that triangle ABC is congruent to triangle DEF. Okay, so that's basically our theorem here. So now we're saying if we have the angle, and the side, we can prove that the triangles are congruent. So let's look at some proofs. So on these proofs, once again, we're going to be all on our own on these proofs. So we are going to have to come up with our statements and come up with our reasons. So let's start with our given information as usual and label our diagram. So it says YZ bisects angle WYX. So this line is bisecting this large angle, okay? Which we know means what when it bisects? It means it cuts it in half. So it means that these two angles would be congruent. All right, then it says angle WYZ. So WYZ, so this little angle here, is congruent to YXZ. So these two are congruent. So let's label that. Okay, so let's start writing down our given information here. So the first thing that was given to us is that YZ bisects angle WYX, and that was given. So always start with the given information. Next thing that was given is that angle YWZ is congruent to angle YXZ, and that was also given. Okay, so those are the two things that were given, but remember, then we went ahead and we inferred something up here from the fact that YZ bisects that angle. So what we decided was that because this is a bisector, this angle here, WYZ, is congruent to that angle XYZ. So that is what we're going to say. So we're going to say angle WYZ, WYZ, so I'm just talking about this angle here. So angle WYZ is congruent to angle XYZ. XYZ. Now, how did I know that those two were congruent? So how did I know that? Definition of bisector. Okay, so that's how I knew that they were congruent. Okay, so now let's think back to what I'm actually trying to do here. So now this part involves some thinking. So you have to now think, okay, I'm trying to do angle, angle, side, right? So I have angle, angle, I have angle, angle. So which side needs to be congruent? This side here. So YZ. So I know that YZ is congruent to itself. So I can say YZ is congruent to YZ. How do I know that? The reflexive property. And then I did it. So let's check it out. I've got angle, angle, side, angle, angle, side. Okay? So now I can write my congruency statement. Triangle W, Y, Z is congruent to triangle X, Y, Z by angle, angle, side. All right, so one whole proof done. Give you a chance if you need to pause and get that copy down. All right, I'm going to go ahead to the next one. All right, we've got 3 proofs here. So number 5 involves parallel lines. Let's see if we can get this one going. So given A, B, C, so A, B, C is congruent to C, E, D. All right, so those two are congruent. Now we've got a parallel statement. So AB, that one, is congruent to CE here. So these two are congruent. I'm sorry, are parallel. And then C is the midpoint of AD. So these two are congruent. Okay, so it's given 3 things. Let's write them all down. So triangle, angle, angle ABC is congruent to angle CED. First thing, given. All right, AB is parallel to CE, given. And finally, C is the midpoint of AD, given. Okay, so I wrote down my 3 givens. Now let's look and write down what I had inferred based on what was given to me. So what I had stated was because C is the midpoint, AC is congruent to DC. So that's what I'm going to write now. AC is congruent to DC. How did I know that? Definition of midpoint. Okay, so now the 5th one, I've done all my givens. I used the definition of midpoint. Now remember, I'm going to need to do something with the fact that those lines were parallel, okay? So I know I'm going to be using, based on my reference sheet, I'm going to be using one of these reasons down here. So altered interior, alternate exterior, or corresponding angles. So let's figure this out. I have a specific angle that I need to prove congruent here. So remember, I'm doing angle, angle, side, okay? So I have angle, angle, side, angle, angle, side. So could I prove that these 2 angles are congruent? Right there. So what kind of angles would those be? So here's my options: alternate interior angles. So are they alternate interior angles? Remember, alternate means on the opposite side. And if you look, these two are actually on the same side of this transversal line here. And this one's actually on the outside as well. So one's on the inside, one's on the outside. So they're not alternate interior angles or alternate exterior angles. So what does that leave us with? Corresponding angles. So they're in the same position. Okay, they're in the same position on those parallel lines. Okay, so we would have corresponding angles as our reason for stating, and let's make this statement here. Angle B A C is congruent to angle ECD. And I know that because they're corresponding angles. All right, and then so finally, because I have angle, side, I can say that triangle ABC is congruent to triangle CED because of angle, side. Okay, so we have two more, and before I go over these two, I would actually like you to try these two completely on your own. So all of the reasons that are going to be in this are reasons you have seen before, you've used before many times. So there's nothing, super different or super new. You might get stuck. I just want you to try them and think about these proofs a little bit, writing the given information. You really, really learn this stuff by doing it. So give these a try and then we will go over them. All right, so hopefully you took some time to try those on your own. Trying both of them gives you a little break as well. So let's take a look at our answers. Okay, so hopefully, if you tried them, then you should have definitely gotten, the first two givens in this case. So it says PR bisects angle QRS, and then angle PSR is congruent to angle PQR. So you could label those things and then you could write them here. So I wrote my given information. Now, so once we have that given, remember, we are writing what we inferred from the given information. So remember, if a segment bisects an angle, that means it cuts it in half. So that means that this angle right here is congruent to this angle right here. So angle PRS is congruent to angle PRQ. Okay, and that is by the definition of bisect, angle, or just angle bisector. So then you have an angle, so then you need that side right here. And then we know that when they share a side, that side is congruent to itself. So PR is congruent to PR, which is the reflexive property. And then we can say that the triangles are congruent to each other by angle, side. So look at that, angle, side. Okay, so number 7, a little bit harder, I think, because again, we do have those parallel lines. So just getting comfortable with identifying those types of angles. So let's take a look here. So we have our given information. They told us that LG is parallel to JM. So these two are parallel. And then we have H is the midpoint of LM. So the midpoint of this segment right here. So we write those two given things. and then we write what we can infer from there. So the first easiest thing, since H is the middle, right? That means LH is congruent to MH. So that's what we have here. So LH is congruent to MH. And that's the definition of midpoint. Okay, so now you had to use two angles. So remember, using your reference sheet, if we're proving angles are congruent, we're going to be using one of these things. So let's take a look at angle G and angle J. Now, you could have actually had these in either order as well. Just FYI. I know this is probably where most people got stuck, okay? So that's totally normal if you got stuck right there, because we're using two different types of angles, and we also really had to come up with that on our own. They really didn't tell us much about the angle. So the only thing they told me was that these sides are congruent. So you kind of had to think, well, if these sides are congruent, I need this angle and this angle. I have to be able to prove that we have this angle side relationship. Angle side. So that's definitely a challenge one. Okay. So here's what we did though. We said, okay, how can I state that G and J are congruent? Okay, they're inside these parallel lines. But they're on opposite sides of this transversal, this diagonal line. So that means that they are alternate interior angles, so G and J. So then I had this angle, I had this side, so then I needed to say that these two angles right here were congruent. And what types of angles are those? Those are vertical angles, so they're opposite from each other. So then we could say angle GHL is congruent to JHM because they're vertical angles. Then we have the angle side relationship. Okay, and that was our last proof. So that's definitely a lot. I know a lot of proofs that we just went over. So now we're just going to spend some more time practicing with all of these proofs.